You're standing in your kitchen. It's 11 at night, and the fridge door is hanging open while you wait for something to reheat in 40 seconds flat. Your phone buzzes on the counter. You don't even look up. Fire is so normal to you, it's basically wallpaper now. A blue ring under a pot. A lighter buried in a junk drawer. A candle you forgot to blow out last week. You control heat with a button. You barely think about it. Twice a day, if that. Now rewind. Rewind past every stove, every match, every lighter that ever existed. Somewhere out there, a small group of hominins is staring into actual flames for the very first time in their lives. They don't know what fire is yet. Not really. They definitely don't know they're about to change what human even means. So here's the real question. It's weirder than it sounds. When did we actually get fire? And did anyone even discover it, technically speaking? Or did we just get lucky? This isn't trivia night material. Fire is the reason you have the brain that's reading this sentence right now. Full stop. Every stove, every candlelit dinner, every ghost story told around a campfire traces back to one blurry, specific moment that nobody actually witnessed. Archaeologists have been chasing that moment for over a century, and the goalposts keep moving. The newest evidence, published just weeks before this video, quietly rewrote the entire timeline. Again, so buckle up, because the real story is a lot older and a lot stranger than the one you probably learned in school. Here's where it gets interesting. Let's start with Wonderwerk Cave, on the edge of South Africa's Kalahari Desert. It's a cave so massive that early explorers reportedly used it as a shortcut instead of a landmark, walking straight through the mountain rather than around it. People have been excavating there since the 1940s, led for decades by researcher Peter Beaumont, slowly piecing together one of the longest continuous human occupation records anywhere on Earth. In 2012, archaeologist Francesco Berna of Boston University published something genuinely startling. He worked alongside Michael Chazan of the University of Toronto and Leora Kolska Horwitz of Hebrew University. Their paper ran in the Proceedings of the National Academy of Sciences. Deep inside the cave, in sediment dated to roughly 1 million years old, the team found something almost invisible to the naked eye: microscopic ash, alongside burned bone fragments. Crucially, this wasn't scattered near the cave entrance, where a passing wildfire could easily explain it away. It was deep inside, tied directly to stone tools made by Homo erectus. To prove it, the team used a technique with a name almost nobody can pronounce twice: Fourier transform infrared microspectroscopy. Think of it as a chemical fingerprint scanner for burnt material. It's sensitive enough to tell the difference between ash that blew in on the wind and ash that was made right there, on purpose, by hand. The results were unambiguous. This fire hadn't drifted in. It hadn't washed in with floodwater either. Someone had built it, inside that cave, roughly 1 million years ago. At the time, that single paper pushed the confirmed record of controlled fire back by around 300,000 years in one publication. For a field that usually measures progress in careful centimeters, that's an earthquake. Suddenly, a species with a brain about 2/3 the size of yours was managing fire, deep underground, 1 million years before modern humans existed in any form at all. Try picturing that for a second. Honestly, a brain smaller than the one in your skull right now, keeping a fire alive, on purpose, in the pitch dark. Chazan himself said the find suggested Homo erectus may have folded fire into daily life far earlier than anyone had proof for. Fire evidence this old is incredibly rare, and there's a simple reason why. Wood turns to ash, and ash blows away or washes out within a few centuries. Finding a 1 million-year-old fireplace that survived intact is a little like finding a grocery receipt from the Roman Empire, still legible. Wonderwerk Cave had exactly the right conditions: dry, sheltered, undisturbed for an unbelievably long stretch of time. It wasn't just old. It was preserved well enough to actually prove intent. Once you know a species that old could keep fire alive indoors, every assumption about their daily lives shifts. warmth on cold nights, protection from predators circling outside the light, maybe even the first excuse for a group of hominins to sit still together after dark, instead of scattering off to sleep alone. Now here's the complication, and you've probably pictured this exact scene before. A genius caveman, rubbing two sticks together, sparks flying, high-fiving his buddies around a roaring blaze. Cut that scene entirely from your head. It's basically fiction, or at least it's not what the evidence actually shows. Archaeologists genuinely can't see an invention moment preserved in the ground. Ash doesn't come with a signature explaining how it got lit. What they can see is fire that was kept, tended, protected, carried into a shelter, and reused over time. And keeping a fire alive is a completely different skill from making one from scratch. Lightning strikes forests constantly, all over the planet, and always has. Grass fires start on their own, with zero human help required. The real trick early humans pulled off probably wasn't conjuring a spark out of nothing. It was noticing a wildfire from a distance, grabbing a smoldering branch before it went cold, and simply refusing to let it die. Some researchers have even proposed that reliable, on-demand firemaking arrived much later than firekeeping did. Strike-a-light kits you could use whenever you needed heat, possibly tens of thousands of years later. In other words, for an almost unthinkably long stretch of time, humans were fire's roommates, not its landlords. They knew how to live with it, feed it, and protect it from rain, long before they knew how to summon it on command. A few sites hint at burned bone even older than Wonderwerk's million-year mark. Swartkrans, also in South Africa, is one of them. Researchers there have dated burnt bone fragments back beyond 1 million years. But that evidence is messier. It's harder to rule out natural wildfire. Researchers are honestly divided on how much confidence it deserves. That kind of open disagreement isn't a weakness in the science, by the way. It's actually the science working exactly the way it's supposed to. Think about how strange that distinction is from where you're sitting. You've probably never once had to keep a fire alive on purpose, for your own survival. Your version of fire maintenance is remembering to change a lighter's flint, or replacing a stove's igniter battery. For hundreds of thousands of years, an extinguished fire meant going without warmth, without protection, without cooked food, for as long as it took to find another spark out in the wild. Let's talk about what happens next. Once firekeeping becomes a habit, not just a lucky break that happened once. Jump forward roughly 250,000 years. You land on a lakeshore in Israel's Jordan Valley, at a site called Gesher Benot Yaakov. In 2004, archaeologist Naama Goren-Inbar of Hebrew University published her findings. They ran in the journal Science, describing something remarkable at this 790,000-year-old site. Burned seeds. Burned wood. Tiny, burned flint fragments, clustered together in specific spots rather than scattered randomly across the ground. That clustering matters enormously. A random scatter of burn marks suggests a wildfire swept through once, indifferent to where anyone happened to be standing. Clustered burn marks, showing up in the same repeated locations over and over, suggest something else entirely. Hearths. Actual, designated fire spots, used again and again and again. The wood species the team identified weren't random either. Olive, wild barley, wild grape, every single one of them edible. Nearby, researchers also found animal bones bearing cut marks. Remains of horses, deer, rhino, and hippo turned up too. These early humans were hunting and processing meat right around that fire. This wasn't just warmth on a cold night by a lake. This was very possibly the earliest hint of cooking. It sat on a lakeshore 750,000 years before agriculture, before pottery, before anything you'd recognize as a kitchen. It's also considered the earliest solid evidence of fire use anywhere in Europe or Asia, meaning humans had carried the habit with them out of Africa. Pause for a second and picture your own last Tuesday. You microwaved leftovers without a single conscious thought. because you've never had to think about it. Meanwhile, a group of early humans beside that ancient lake were doing something that took real planning. Gathering specific kinds of wood, protecting a flame from wind and rain, returning to the exact same spot night after night for reasons that had nothing to do with luck. That's not an accident you stumble into once. That's a routine, repeated on purpose. And once a group develops a shared routine, you start to see the earliest outlines of culture forming around it. But here's the question that should be sitting in the back of your mind by now. A routine for who, exactly? A single hearth, used a handful of times, isn't the same thing as fire becoming a daily habit. Not for an entire community, generation after generation. That's where the story gets even stranger. Because the next major site doesn't just show fire being used, it shows fire becoming furniture. Turns out, the clearest answer to that question comes from Qesem Cave, just outside modern Tel Aviv. Researchers there were led by Ruth Shahack-Gross of the Weizmann Institute of Science. She worked alongside Avi Gopher and Ran Barkai of Tel Aviv University. In 2014, the team published a study in the Journal of Archaeological Science describing a hearth sitting dead center in the cave. This wasn't a small campfire. It stretched over 4 square meters wide. Layer after layer of ash showed it had been rebuilt and reused, again and again, across generations of occupants. It sat right next to an area where animals were routinely butchered, with burn temperatures in some spots reaching around 500 degrees Celsius. That's hot enough to warp bone. Meat got processed right there. Fire sat right there too. Close enough that the connection wasn't a coincidence. Shahack-Gross herself called it a turning point. It marked the shift from occasional sporadic fire use to something genuinely habitual. Something you could practically set a clock to, if clocks had existed yet. Qesem Cave was occupied for roughly 200,000 years. Researchers believe fire was used there consistently for meat roasting and cooking throughout that entire stretch. Roughly 300,000 years ago, fire wasn't a rare special event anymore. It was Tuesday. It was the literal center of the room, the way your kitchen island probably is right now, minus the smart speaker quietly listening in on you. The people at Qesem weren't primitive by any measure that matters to you. Excavators there also found evidence of systematic flint recycling, coordinated group hunting, meat-sharing practices that hint at real social structure. Some of the teeth recovered from the site don't cleanly match Neanderthals or early modern humans. A few researchers suspect Qesem's residents belong to a lineage we don't fully understand yet. Whoever they were, they'd built an entire daily rhythm around a fire that barely went out for 200,000 years straight. Imagine trying to keep any single habit going that long. Your gym streak doesn't stand a chance by comparison. There's another detail worth sitting with. That central hearth wasn't hidden in a back corner, away from the group. It was placed deliberately in the middle of the living space, the way a fireplace anchors a modern living room, or the way your kitchen table pulls everyone toward it at dinner, whether you actually want to talk to your family that night or not. Whoever built that hearth understood something about human gathering that hasn't really changed in 300,000 years. Fire wasn't just fuel. It was a reason to sit down together, in the same spot, on purpose, night after night. Compare that to the earlier sites for a second. Wonderwerk gave us fire that was kept alive. Gesher Benot Yaakov gave us fire that was used for cooking. Qesem gives us something closer to a home, a fixed point in space that a whole community organized its evenings around, for longer than most modern nations have existed, combined. So by 300,000 years ago, the picture looked pretty settled, at least on paper. Fire control at 1,000,000 years, at Wonderwerk. Fire-based cooking by 790,000 at Gesher Benot Yaakov. Fire as a daily fixture by 300,000 at Qesem. A tidy staircase, climbing steadily toward you. Every textbook could basically stop there, and for years, most of them did. Except archaeology has a habit of not staying settled for very long. And the next update didn't just add a new site to the list. It went back and rewrote the oldest one already on it. In 2026, the very same research group behind the original Wonderwerk discovery went back to the cave. This time, they came armed with a brand new method. One specifically built to detect burning inside fossilized bone that older techniques simply couldn't catch. The findings were published in the journal PLOS 1, with Leora Kolska Horwitz involved once again. And the results are genuinely wild, burned bones, sitting in layers dated between 107 and 79 million years old. Not near the mouth of the cave, where daylight and wind could reach. Deep inside it, in spots a wildfire could never have physically reached on its own, no matter how big or how lucky. Horwitz put it plainly. These early humans weren't passive bystanders, watching nature burn from a safe distance. They were actively engaging with fire, hauling it into a cave, keeping it going, nearly 8 million years ago. That's almost double the confirmed timeline that had stood for over a decade. To be clear, this doesn't mean these early humans could strike a flame on command whenever they wanted one. The study itself is careful not to claim that. It means something a little more unsettling, honestly. The relationship between hominins and fire is older, weirder, and far more tangled than anyone confidently stated even a few years ago. Back when this exact video might have quoted a completely different number. Sit with that figure for a second. 79 million years. That's not modern humans. Not even close. That's not even the Homo erectus you're probably picturing from a museum diorama. That's some of the earliest members of our entire genus. Full stop. Already dragging burning branches into the dark. Hundreds of thousands of years before Wonderwerk's original. Already record-breaking date. Researchers still don't know exactly which hominin species deserves the credit for these earliest fires. The dates overlap with the tail end of Homo habilis and the emergence of early Homo erectus. The bones themselves can't tell you who lit the match. They can only tell you that something in that cave got hot, repeatedly, in places nature alone couldn't reach. That uncertainty isn't a flaw in the research. It's an honest admission that the fossil record for this exact window is thin, and everyone studying it knows it. What's genuinely remarkable is the timing of all this, for you specifically, watching this right now. This isn't some decades-old textbook fact you happen to miss in school. It's a discovery that landed in the scientific literature only weeks before this video did. Statistically, there's a real chance this number gets revised again before you finish watching your next 10 videos on this channel. So why should you care beyond an extremely old campfire? Here's the payoff, and it comes from an unexpected place. Not archaeology, but biology. In his 2009 book, Catching Fire, Harvard primatologist Richard Wrangham laid out an idea that's become known as the cooking hypothesis. It's the closest thing this story has to an answer for why any of this shaped you. His argument goes like this. Somewhere around 8 million years ago, Homo erectus underwent a strange, remarkably sudden shift. Brains got dramatically bigger. Guts got noticeably smaller. Teeth and jaws shrank down, no longer built for hours of grinding tough raw food. Wrangham's explanation is elegant, on its surface. Cooked food is simply easier to extract calories from, and easier to digest. That frees up energy that used to go entirely toward processing raw food, all day long. That spare energy, he argues, got redirected straight into growing a bigger, more expensive brain. This connects to something researchers call the expensive tissue hypothesis, first proposed by Leslie Aiello and Peter Wheeler. It links smaller guts directly to the metabolic budget available for larger brains. It's a genuinely elegant idea. It's also seriously debated. Critics point out that solid archaeological proof of fire that old has always been thin. Almost suspiciously thin for something this evolutionarily important. Some researchers have even run experiments comparing raw versus cooked diets in lab animals. The results were mixed, sometimes contradictory, and they haven't exactly settled the argument either way. That's exactly why the new Wonderwerk dates matter so much. They don't prove Wrangham right, and honest scientists won't claim that they do. But they close the gap, meaningfully, between when the biology changed and when we can actually show fire was there to explain it. Absence of evidence was never evidence of absence. In this particular case, it just took 100 years and a much better microscope to go looking properly. Think about it this way for a second, about your own body. If cooking really did rewire an entire species' anatomy, then the fire you use without thinking every single evening isn't a convenience layered on top of being human. It's arguably a precondition for it. Your smaller jaw, your smaller gut, the sheer amount of energy your brain is burning right now just to process these words. All of it may trace back to one decision some hominin made. Roughly 8 million years ago. A decision to keep a stolen ember alive instead of letting it go out. Here's a genuinely wild way to think about it before we go. The device in your pocket right now exists, in a roundabout but very real sense, because a smaller, stranger brain once sat beside a captured flame and simply refused to let it die. The stove in your kitchen is a distant, direct descendant of a lakeshore hearth at Gesher Benot Yaakov. Your habit of coming home and cooking the exact same meal, without thinking twice about it, is genuinely the same habit Qesem Cave's residents had. That was 300,000 years ago, just with dramatically better lighting, and somewhere in the pitch dark of a South African cave, nearly 8 million years ago, the very first version of that habit was already forming, one stubborn, protected ember at a time, if you had to guess. Drop it in the comments. How much further back do you think the next discovery is going to push this timeline? 2 million years? Further than that? This exact field has quietly rewritten the earliest evidence roughly once a decade for 50 years running. Don't bet against it moving again. Picture it one last time. Your stove. That ancient lakeshore hearth. Qesem Cave's fire, rebuilt patiently, night after night. And somewhere deeper, further back, before any of that, in the dark. It never actually went out.